You've heard the words climate change pretty much everywhere, right? On the news, at school, all over the internet. It feels like one of the biggest, most talked about topics of our time.
But what does it actually mean? Is it really just about the weather getting a bit hotter and, why does everyone say it matters so much? Well, we're going to break it all down really clearly and simply so you can get your head around exactly what is happening to our planet.
Okay, to really understand climate change, we have to start right at the beginning. And that means getting clear on two words that people mix up all the time: weather and climate. See, weather is what's happening outside your window right now. Is it sunny? Is it raining? That's the weather. It's short-term, it changes day to day. Climate, on the other hand, is the big picture. It's the average weather pattern in a place over a really long time. We're talking 30 years or more. So think of it this way. A surprisingly hot week in October in the UK, that's weather. The fact that the UK generally has cool, wet winters, that's its climate. And that's the most important point to get. Climate change isn't about one weirdly hot summer or a single snowy winter. It's about a fundamental shift in the entire pattern, the long-term average for the whole planet.
So let's ask a basic question. How does our planet stay warm in the first place? Well, it's all thanks to something called the greenhouse effect. It's actually pretty cool. Imagine our atmosphere works kind of like the glass in a greenhouse. Energy from the sun beams down and warms the planet. Then some of that heat tries to bounce back out into space, but certain gases in our atmosphere trap it, keeping Earth at a nice, livable temperature. Just how important is this? Well, without the greenhouse effect, the Earth's average temperature would be this, -18 degrees Celsius. Seriously, a frozen world, way too cold for most of the life we know to even exist. So let's be absolutely clear on this. The natural greenhouse effect is not the bad guy in this story. Not at all. It's our planet's life support system. It is the very reason Earth is a vibrant, living world, and not just another frozen rock floating in space. The problem only starts when we mess with that delicate balance. And that brings us to what scientists call the enhanced greenhouse effect. Basically, human activities are pumping extra greenhouse gases into the atmosphere. It's like we're making the glass on that greenhouse thicker, or throwing another heavy blanket on the bed when you're already warm. That natural, helpful layer of gases gets too thick, and it starts trapping way too much heat. So what are these extra gases? Well, the main one you've probably heard of is carbon dioxide, or CO2. That gets released when we burn fossil fuels like coal, oil, and gas to power our world. But there are others too. Things like methane, which comes from farming and landfills, and nitrous oxide from the fertilizers used to grow our food. All those extra gases trapping all that extra heat has caused the Earth's average temperature to rise by about 1.2 degrees Celsius since the 1800s. Now, I know what you might be thinking. 1.2 degrees? That doesn't sound like a lot. But for the climate of an entire planet, it is a huge deal. It's a tiny number with enormous consequences. So, what does that warming actually look like in the real world right now? Let's look at two urgent facts that bring this home. Fact 1. The year 2023 was officially the hottest year humans have ever recorded. And it wasn't just by a little bit, it completely smashed the old records. At the same time, our oceans also heated up to their highest ever temperatures. This isn't a projection for the future. This has already happened. And fact 2, carbon dioxide is incredibly stubborn. Once it's up in the atmosphere, it can stay there, trapping heat for hundreds of years. Just think about that. It means the CO2 that was released from a car journey way back in 1990 is still up there right now, still warming our planet. So even if we stopped all emissions today, the warming from the stuff we've already put up there would continue for a long, long time. Okay, that was a lot of information to take in. So let's do a really quick knowledge check to see what's stuck. I'll ask 5 questions and give you a 4-second pause to think after each one. Ready?
Question 1. What is the difference between weather and climate?
And the answer, weather is short-term, what's happening now. Climate is the long-term average, over 30 years or more.
Question 2. What would Earth's average temperature be without the natural greenhouse effect?
The answer is a super chilly -18 degrees Celsius.
Question 3. What's the most significant greenhouse gas that comes from human activity?
That would be carbon dioxide, or CO2.
Question 4. By approximately how much has the Earth's average temperature risen since the pre-industrial era?
The answer is approximately 1.2 degrees Celsius.
And finally, question 5. Can you name one other greenhouse gas besides carbon dioxide?
You could have had methane or nitrous oxide. Well done. How'd you do?
So now you know what climate change is. But the next big question is, how do scientists actually know all this is happening? Next time, we're going to dig into the evidence, from ancient ice cores deep in Antarctica to melting glaciers and rising seas. The proof is everywhere. Join us then.